Good morning, class. I'd like us to proceed from where we reached yesterday. Yesterday we were covering the naming of branched alkanes, and today we are going to do isomerism in alkanes. The objective for the lesson is, by the end of the lesson, every learner should be able to draw and name 3 isomers of pentane. And to demonstrate isomerism, we are going to use the models here. We are going to use the purple balls to represent carbon atoms, red balls to represent hydrogen atoms, and the white sticks to represent the bonds between carbon and carbon atoms, or carbon and hydrogen atoms. So pentane molecule normally has a molecular formula of C5H12. That is 5 carbon atoms. That is first carbon atom. I join the second one, the third one, the fourth one, and the fifth one. Those are 5 carbon atoms making up the pentane. Then I join the hydrogens. That's the first hydrogen, the second one, the third one. You are supposed to be observant. Each carbon atom is supposed to have a maximum of 4 bonds. That is 1, 2, 3, 4. So that one is fully bonded. For the second carbon atom, I add 2 hydrogens for it to be fully bonded. It has 1, 2, 3, 4 bonds. The third one, I put 2 hydrogens. The fourth one, I put 2 hydrogens. It is fully bonded. And the last carbon atom, I put 3 hydrogens for it to be fully bonded. That is the first isomer of pentane, and this is the pentane itself. It has 5 carbon atoms, 1, 2, 3, 4, 5, and 12 hydrogens. So when we talk about isomerism or isomers, isomers are compounds with the same molecular formula but different structural formula. So how do I rearrange these atoms? I use all of them. I come up with a different structure with a different name from the one that I have here. So let me try to rearrange this. If I remove this first hydrogen, I put it at the rear end, right there. Do you notice any difference between whatever I had initially, the first molecule, and what I have here? There's no difference. So you're not allowed, or for you to come up with a different isomer, you cannot remove the first hydrogen and attach it to the last. Remove the first carbon and attach it to the last carbon, and then think that you have come up with a different molecule. No, you still have the same molecule that you had initially. So what I'll do is I'll detach this first carbon. Then instead of attaching it to the last carbon, I attach it to carbon number. This is the last carbon. Then in that case, for the hydrogens, I have to be careful that every carbon must have a maximum of 4 bonds. These are 1, 2, 3, 4. So that is the second isomer of pentane. For its name, that is carbon number 1, 2, 3, 4. There are 4 carbon in the longest continuous carbon chain. There are 4 carbons, meaning the parent name for this molecule is going to be a butane with 4 carbons in the longest chain. But in total you have 5 carbons. So the molecular formula has not changed, but the structure has changed. So the IUPAC name for this molecule is going to be carbon number 1, carbon number 2. We are going to call it 2-methyl. Why do I call this methyl? It's a carbon with 3 hydrogen atoms. That is a methyl group. It's a substituent group. So this is 2-methyl butane. That is the second isomer of pentane. For me to come up with the third one, I can rearrange this further. What do I do? I rearrange this further. I remove this one and this one. Then this put it there. That is the last isomer of pentane. As you can see, I still have used all the atoms. The longest continuous carbon chain has 3 carbon atoms. That is 1, 2, 3. If I count it differently, 1, 2, 3. If I count it differently, 1, 2, 3. So the longest carbon chain has 3 carbon atoms. All the hydrogens are used. That is 12 hydrogens. So this is the last isomer of pentane, and its name is going to be in carbon number 2. That is carbon number 2. Carbon number 2, we have 2 branches. That is the first branch and the second one here. This branch is a carbon with 3 hydrogens. That is what we call a methyl group. So you have 2 methyl groups. That is the first methyl group and the other one on this other side. So this one is going to be, since they are all attached to carbon number 2, we are going to call it 2, 2, because there are 2 methyls. Di means 2. So you're going to have 2, 2 dimethyl propane as the last isomer of pentane. Thank you.